So in this video, we're going to talk about hot adding hardware to a running virtual machine, which is really very handy, right? We can make changes as necessary without having to take those virtual machines offline. It's pretty easy to do with networking and disks. There's a little bit more details when we start talking about CPU and memory. So for hot adding a network interface or a disk, you really don't need to do much of anything at all. We can just go edit the settings of that virtual machine and add the disk that we want and connect it potentially even to a different SCSI controller if we need to, or to even use a different SCSI driver. So if we want to use PV SCSI compared to, the LSI logic driver or something, and pretty easily supported, basic hot swap, plug and play type stuff. And your guest OSs should have no problem doing this. There are limits, we can have 10 virtual network cards and we can have up to 60 virtual SCSI disks actually, which is a lot. But if you use the PV SCSI driver, you can actually push that up to 255, which seems like a lot of disks for a virtual machine. But anyway, you could do it and you can start small and grow your virtual machine allocations as necessary, right? Now, when it comes to hot adding CPU and memory, that's a little bit different. So what we typically want to do is not over allocate CPU and memory to a virtual machine. We don't want it to use more resources than it needs. ESXi is pretty good actually at not giving access to resources that the machines don't really need. But still, the machine's going to think it's working in a certain kind of environment. It's going to tune its workload a certain way. We don't necessarily want to do that. So over-declaring resources for our virtual machines is not necessarily a great idea. We'll talk more about reservations and limits in the performance video. We do have the ability, if the guest supports it, to enable hot adding of CPU and or memory to a running virtual machine. So this is pretty well supported in Windows Server 2008, and it's somewhat less supported in Windows 2003 and Linux. SQL Server requires you to go do a little bit of extra work to recognize the additional CPU, however, and, this has actually got a licensing restriction to it as well. In Windows 2008 anyway, this requires a Data Center Edition license, whereas in Windows 2012, it's a standard edition feature. So yes, you can do this, but once again, you're going to want to take a look at what your operating system running inside the guest supports, what the applications support, and how they're all going to react when you start doing these things. And it may not be exactly the way you would expect. It also has a performance impact in VMware. So this virtual machines to be somewhat ready to receive new hardware, or at least this is why Windows is able to do this pretty easily, is because there's a whole bunch of things that get optimized differently when you enable this, and it maxes out a lot of its, memory allocation tables and things like that. It's not a huge amount of overhead, but there is some. But also, if you're using virtual machines with lots of CPUs, then you don't actually want to be doing this because you're potentially going to break the relationship between NUMA, which is a feature where we can group memory access and CPU together on machines with lots of CPU cores, and Vnuma, which actually extends that into the virtual machine so they get the same benefit. So whenever you're using virtual machines that have 8 CPUs or more, I assume at this point you probably have a machine that does support hardware NUMA, and you would want to get Vnuma into the virtual machine, so then you should not do this. And again, these features also may be supported differently depending on the OS or the application. So SQL Server supports Vnuma, but Exchange Server doesn't. And VMware's got a knowledge base article that breaks a lot of this down. So we'll take a look at the features to enable this, and you'll have to decide whether or not it's really worth it for you and whether this is supported under your licensing and, technologically by whatever you're running in your guests. So we can have up to 128 virtual CPUs now for a virtual machine in ESXi 6. So that's not necessarily a good idea, and we don't really want to go overboard with allocating more virtual cores than we really need. And of course, our needs may change over time. So we can't remove virtual cores while the system is running, and I can't change this option while the system is running, but I've got this one shut down. So if I go to the options, you'll see we have support for memory and CPU hot plug. So if I turn on memory hot add and or CPU hot add, I can specify that we can then just go add a CPU or more memory to this virtual machine while it's running. And that's going to be useful. I can start with a lower number of CPUs, and if I think I really need them, I can start allocating more. That could be a temporary condition. There's other things that you can do in VMware to manage load, and just adding hardware to those virtual machines is not necessarily going to give you the effect that you want. It's never going to use more cores than you allocate for it. So if I give it 2 physical cores, I've got 120 physical cores in the system. It's not going to use more than 2 cores, but it will use those 2 cores at the same time. So oversubscription is great. Virtualization gives us lots of opportunity to do that, but we have to do it in a reasonable way. And, there's limits to what we're capable of accomplishing. So in summary, don't do this unless you really need to. But at the same time, don't over-allocate hardware for virtual machines that they're not going to need and that make VMware do things that are less than effective. We'll talk more in the performance videos about things like resource pools and reservations to try and manage this workload a little bit more effectively. And in the next video, we'll talk more about the VMXNet 3 and PV-SCSI drivers that we can use to get more virtual machine awareness into our virtual machines.